Hi everyone, welcome to this quick guide video that talks about the concepts on the separation and purification techniques which we have learned in the chapter of experimental chemistry. Now, this actually applies to both students who are looking at science chemistry as well as students who are looking at pure chemistry because most of the techniques we have learned are pretty much the same except for slightly additional ones for those who are taking pure chem. Now, in this particular part of the chapter, there are two key ideas that you need to take note of. First and foremost is really how do you familiarize yourself with the various techniques, because you have learned so many different techniques such as filtration, crystallization, so on and so forth, right? So you do need to know what are the different techniques and more importantly, what are their objectives. Are you trying to get a solute? Are you trying to get a solvent? What exactly are you doing for each of the techniques? Next, you must know what are the steps that's required. So for instance, in crystallization, we talk about things such as heating until the solution is saturated. So for instance, heat till solution is saturated. So such steps are crucial because it helps you to carry out the experiment when you are being required to do so on yourself, right? So there are various steps for each of the different techniques. But of course, we are going into the notes once again. I've actually attached over here in this screen 3 very helpful QR codes and the respective URL link. And they're all being produced by this company called cognitoedu.org. So these YouTube videos are actually very useful summaries on the various techniques we have learned so far. It provides interactive images and animations to help you understand how these various techniques actually work. But of course, just like all summary videos, as per the one that you're watching right now, they only provide you with a quick glimpse into what the concept is about. You will still need to refer to your notes, your textbook, and also the workbook and the worksheets that you have been doing to gain a better idea of what the exact concepts are about and how do you sharpen the way you understand the various concepts. So although there's only 3 videos being shown over here, as you explore and you have the time to take a look at this YouTube channel, as it really provides a whole range of very useful concepts, and not just on chemistry but also on biology, physics, as well as generally for science as well. So feel free to explore them. So for this particular video, I won't be recapping on the various techniques because I think you have heard it various times in class, and you can also take a look at all these videos for a quick summary. What I want to focus on today is what actually most students struggle with, which is a case whereby you are given a mixture. Now, we know that mixtures is actually a substance that's made up of 2 or more substances that are not chemically combined together. Now, so for example, if you have a mixture of chemicals A, B, and C, what this means is that they are actually all not chemically combined together, and there is a way for you to actually separate them out back into A, B, and C. But what most students struggle with is we have learned so many different techniques, right? How do I know which one to choose, right? You learn about filtration, crystallization, so on and so forth. So this video is really focusing on, hey, if you are given a certain mixture, how can you make the various deduction and the various steps to derive, should I use filtration, should I use crystallization, or what should I do in order to get the different chemicals. So that is the focus of this particular video. So let's take a look at what you need to consider. Specifically, when you are looking at a question regarding mixture, so if I draw your attention to just the first line at the top of the page, I know there's a lot of words here. We'll zoom into each of the respective arrows. There's a need for you to take note of what is what I call the distinct property of that particular chemical that you want. So what do I mean by distinct property? So for instance, if you are given a mixture of sand and salt, and you know that both of them are actually solids, so they're all mixed together very well. So for instance, let's say you have a beaker here, and within it you have a bit of sand and you have a bit of salt, right? But you can't really tell them apart, and you are not too sure how to physically separate them just using your hand and sorting them out. What could you do that allows you to apply the concept of chemistry in order to separate them? The thing that you need to think about is what is the distinct property. Now, distinct property means what exactly makes the particular chemical more unique than the other one. So for instance, when you look at sand and salt, right, they are both solids. But if you think a little deeper, you realize that, hey, salt is actually a soluble solid. Now, soluble means it can dissolve. Whereas if you look at sand, it's something that we call an insoluble solid, which means that it cannot dissolve in water, for instance. So what we could do is actually to first say, let's add in water. Now when we add in water, you realize that, hey, the salt will be gone now because you have dissolved inside and you are left with just the sand, right? So this is what you're left with. This is now what we call salt solution because the salt is gone. It has dissolved inside the water. And you still have your sand staying inside. Now once you have done that, that's where you can do the next step, which is to separate out the sand. So now, same thing, we ask ourselves, what is the distinct property of sand? What makes sand so unique in this whole setup? And we realize that, hey, sand is actually insoluble. That means it's the only solid in this whole setup now. There's a solution, but there's also sand, which is a solid inside. So what do? That's where we use this idea of filtration. So in filtration, we will separate it by pouring the mixture into this filter funnel that's lined with filter paper, and then we collect what we call the filtrate that flows through. So in this case, the filtrate will be your salt solution, and you'll be left with your residue, which is the sand at the top. So once you have done till this step, indeed we have already separated the sand from whatever we are looking at. But if you think about it for a second, we started with salt, but we ended with salt solution. Something is not right. We want to end up with salt. Then that's when we ask ourselves again, this is salt solution. What is the distinct property that can be used of to separate the salt out from the whole thing? And if you think about it, you realize that, hey, in salt solution, what it means is that the salt is dissolved in the water. So is there a way for me to actually remove away the water so that the salt can be left behind? And we move to the last step, which is actually this idea of evaporation to dryness. So when you look at this entire flow chart, right? A flow chart is basically a systematic way to look at how can we do step-by-step analysis of what's going on. And you realize that if I do it in this manner systematically, starting with sand and salt, thinking about what makes them different, distinct property, what makes them different from each other. So I talk about one being soluble, one being insoluble. That's when I can think of what's my next step. After my next step, same thing, I ask myself, what makes them different? Then I decide to use filtration. Thereafter, I also ask myself, what makes the salt different from the water that is inside? Is that the salt is actually dissolved within the water. So if I can remove away all the water by evaporation to dryness, that's where I can end up with the salt. So that is what we mean by distinct property. Okay, so we're going to try to apply this whole concept back to the previous page, but this time we're going a bit deeper by first asking ourselves, can we first understand what kind of mixture do we have? So on this screen, I know there's a lot of writings, but I'll just zoom into 3 key concepts first before I go even smaller to the minor details. First, your mixtures, right? They could either be solid-solid mixture. What do I mean? That means I give you 2 or more solids, they're all mixed together. Or it can be solid liquid mixture. That means I give you a solid and it's mixed with a liquid. The solid may have dissolved inside, or maybe it didn't dissolve, right? We wouldn't know. Or I could give you a case whereby you have liquid-liquid mixture. That means the 2 liquids or more are actually mixed together. So we're going to take a look at the first one, which is the one on the extreme left on solid-solid mixture first. So let me just zoom into this portion. So for solid-solid mixture, right, there is actually 2 possible scenarios. One is whereby both of the solid are actually both insoluble. That means they are, for example, sand and rock, right? They are all insoluble. Or you can have a case whereby, hey, you have an insoluble solid, but you also have a soluble solid, which is like the example that we spoke about. For example, sand and salt. Right? So there's 2 possible scenarios depending on whether the solids are soluble or not. Let's take a look at the left one first. If you're given 2 solids that are insoluble, now you can't add water to separate them because it doesn't make a difference. So that's where you ask yourself again, hey, can I know whether the solids are actually solids that can be attracted to by the magnet? Right? So for instance, if one of the solid can be attracted by the magnet, if you take a look at this diagram here, what you'll see is that the magnet will be able to pull out, one of the solid up, and in this whole process, remove it from the other solid. But in order for this to happen, one of it must be magnetic, right? So we talk about what exactly is magnetic chemicals, right? So examples of magnetic chemicals will be things like iron, will be things like steel, will be things like nickel, so on and so forth, right? So there's only a few that are magnetic in your syllabus. Okay, so first and foremost, you must know whether they are magnetic or not. Then this whole process of magnetic attraction can actually take place, right? Because if they're not magnetic, then you put a magnet there, nothing is going to happen. Okay, so you need to be magnetic so that when you put a magnet, it's going to attract the magnetic substance. The other process, which we learn a lot more in terms of in pure chem, is this process of sublimation. Now, what is sublimation? Sublimation means that there is a process whereby you can go from solid to gas. That means this only occurs for certain chemicals. So what are some of the chemicals? For example, you have iodine, you have this chemical called naphthalene, or commonly found in what we call mothball, you have your dry ice, and of course you have this chemical called ammonium chloride. So all these chemicals can go through sublimation. That means if you provide a little bit of heat, what you realize that if you look at this diagram here, imagine the white one is the one that can sublime. When you heat it up slightly, all these white ones will actually turn into gas. So turning into gas means that they would kind of disappear from your eyes, right? Because they become vapors moving upwards. Then at the top of the sublimation, you leave a cool surface, and when it touches the top, that's where they will condense or deposit back to form the solid. And by doing so, you have separated your white solids from the one that's green in this picture. Okay, so that's sublimation. So how do we tell that? We ask ourselves, hey, can I have a solid that can sublime? Right, then that's where you know that that is the method to go for. But that is only if you're looking at the insoluble and insoluble solid. So you need to think a bit more about what is the distinct property. However, once you have an insoluble solid and soluble solid set up, it makes things a lot easier because one can dissolve, one cannot dissolve, right? So all you need to do is actually, like what we did, for example just now, we add water. After adding water, we realize that one of it has dissolved, then we do a filtration, right? So this will be similar to what I shared earlier. And that is for solid-solid mixture. So if you think about it, the three big ideas in this part is that you must first know what kind of mixture are you dealing with, right? You must know whether the question is giving you something about solid-solid, or is it about solid-liquid, or is it about liquid-liquid, right? So that we talked about the first one already. Now we zoom into the solid-liquid one. So for the solid-liquid one, of course you can have a case whereby the solid is insoluble and you give it a liquid. For example, I give you water and within it I add in sand, right? So sand is not soluble in water. What happens? You do a filtration. So you can just remove the substance, you have your residue, and you have a filtrate, clear cut. So I think most students are quite okay with such concepts if you have an insoluble solid in a liquid. However, it gets a little tricky when you have a soluble solid with a liquid. That means the solid will have dissolved inside this liquid now. So if this happens, a soluble solid and a liquid is mixed together and the solid is dissolved inside, and you want to get the solvent. Now the solvent refers to the liquid, right? So if I want to get the liquid back, what I can do is this method of simple distillation. So most students are also quite understand the concept of simple distillation. Basically, it's a setup whereby you collect the solvent, you will actually evaporate, go through the condenser, then you will drip out as the distillate. So that is simple distillation if you want to get the solvent, right? But what if I want to get the solid? So remember, inside here there's a solid and there's a liquid, right? So what if I want to collect the solid this time around? The liquid, I don't really care about liquid. So that's when you need to think about whether this solid itself, will it actually be affected if you heat it up too much. Now, when a solid is heated up, some of them may go through this process called decomposition. So for example, sugar. We learn in lower sec or in primary school that when you heat up sugar, sugar will actually decompose and form a black solid. On the other hand, if you have solid that is not likely to decompose, for example, salt, right? So like what we use for cooking, we add salt to food, but the salt will just stay there. Then it actually affects what method do you use. So for a solid that will decompose, so under the yes section, we must use this method called crystallization. Crystallization is a process whereby we will heat until the solution is saturated, allowing the solution to cool down to form crystals. Then we'll do a filtration to collect the crystals. Then we'll rinse, filter, and dry the crystals. Right, so this is what crystallization is about. And it's meant when the solid will decompose when you are heating it up too strongly. So in order to avoid that from happening, we will stop the heating once the solution is saturated, then we let it cool down, then the crystals will come out. But if you're dealing with a solid that actually is quite resistant to heating, for example salt in this case, right, must remember that first and foremost the solid must be soluble. So it's not any random solid that's resistant to heat. We're talking about a soluble solid, but resistant to heat. Then you can just evaporate the whole solution to dryness. Then you'll be left with the solid itself. So that is something to think about. And I think generally, most students would struggle with this particular part of the process, whether we use evaporation to dryness or when do we use crystallization. So it's worth thinking a bit deeper, or you can refer to the video. I think it's video number 2 from the previous page to take a look at what is the different process and why do we use different methods. So coming to the last type of mixture, a liquid-liquid mixture. Now when it comes to liquid-liquid mixture, right, it really depends on whether the mixture is consisting of miscible liquids or immiscible liquids. So miscible liquids means they can mix, and when they can mix together, actually you cannot tell them apart. So it makes it very hard for you to separate them. Immiscible means that they cannot mix. So for example, oil plus water, right? So oil and water, we know that when we put them together, they are not able to mix well, so they actually separate into 2 different layers. And once they do that, the way to separate them is that we can use this thing called separation funnel, right? So whereby you can have, for instance, the oil at the top, then you have water at the bottom, right? Because oil has a lower density, it's going to float on top, whereas the water is going to stay at the bottom. Then you can release the water out, but keep the oil at the top. So that's how you separate the two, provided that they are what we call immiscible liquids. However, if they actually mix well together, then that's when we need to use this method called fractional distillation. So fractional distillation, if you recall when you look at the diagram itself, it is a setup that looks quite similar to simple distillation, but it has this part that we call a fractionating column. So what it does is that it helps to allow for the substance with the lower boiling point to actually be collected first. Okay, so what fractional distillation does is that we look at boiling point, right? So the chemical that has a lower boiling point will rise up first, then you'll move through a condenser, then you'll drip out as the distillate. Whereas the chemicals with a higher boiling point will not be able to exit the fractionating column. It will just keep condensing and falling back and over again. So this is when we know that we use fractional distillation. So all in all, what I want to highlight over here is that although we have learned various techniques, at the end of the day, we do need to ask ourselves, how do we know when to use which technique? And that's where I talk about this idea of distinct property. So when you look at a question, when you're given a mixture, ask yourself this question: am I first looking at a solid mixture? Or am I looking at a solid liquid mixture? Or am I looking at a liquid mixture? Next, ask yourself, are there differences in terms of solubility? Most of the time we can think about it in terms of solubility. If there's an insoluble and a soluble one, what can we do? So on and so forth. But once you really identify that it is a solid liquid mixture and it contains a soluble solid with liquid inside, and you want to get the solid out, now that's when you need to think about, hey, do I have enough idea or information about whether the solid will decompose or not. More often than not, we'll be very clear when we're asking you, are we collecting a crystal or are we collecting something that can decompose? So we will try to give you as much of this information as possible so you can make an intelligent deduction from that. Okay, so with that, I've come to the end of this video. Feel free to check out the other videos or check in with your teachers if you have any questions. Thank you and goodbye.